welcome to the Analog Communication Engineering playlist. Here in this session I will be going to explain the DSBSC AM signal generation using ring modulator circuit. Hence I will first explain in this session the circuit of ring modulator. Then I will also explain the two different mode of working of the ring modulator circuit. Then again we will observe the output waveform of the ring modulator, and lastly we will also observe the frequency spectrum. So let us begin this session with the basic circuit of ring modulator. So first you need to know that ring modulator is basically a type of switching modulator. Okay, I already explained the working of switching modulator circuit. You please, if you want to know, you go through my previous lecture, which is basically used to generate a DSBSC signal. So ring modulator is used to generate a DSBSC signal, which is actually working on the principle of switching modulator. Okay. Now in a ring modulator circuit, basically four diodes are connected like this. Okay, 1, 2, 3, 4. In a ring formation, four diodes are connected. So ring modulator circuit, four diodes are connected in a form of ring, in which all four diodes are connected in the same manner and are controlled by a square wave carrier signal. Here you see that all four diodes, 1, D1, D2, D3, D4. So four diodes are there and it is controlled by a square wave signal. Here it is noted as WT. This is a signal of square wave. We all know, right? Now, two center tap transformer are used. Here, this transformer, two transformers are there. I am noting it 1 T1 and T2. So it is visible. So two transformer here. This transformer has a special type of transformer that is known as center tap transformer. You already know what is center tap transformer. So two center tap transformer are used. The message signal MT is applied to the input transformer T1. Here it is the input transformer, which is T1. Here MT is my message signal. So MT basically applied to the primary winding of the transformer T1, input transformer, right? Whereas the carrier signal CT is applied between the two center tap transformers. Here you can see this carrier signal WT is applied between two center tap transformer, T1 also and T2 also. Okay, so both center tap transformer is connected with the square wave signal. Therefore, the ring modulator circuit is widely used in carrier telephony system as an application. Okay, so we know the basic essential components of a ring modulator. That is ring modulator. What are those? That first principle is ring modulator will be working on the switching modulator principle. Then it must consist four diodes where two transformer. When message signal is varying to the input transformer T1 in the primary winding, and the carrier signal will be connected to the two center tap transformer. Okay, so this is the primary, you can say primary components or primary circuit of the essential components of the ring modulator. Now the operation. The operation of ring modulator is explained with the assumption as the perfect switch, because I told you that the main principle of ring modulator is based on the switching modulator. What the switching modulator I have already explained you in the previous lecture, switching modulator and demodulator both. So please go through it. If you don't understand what is the meaning or principle of switching modulator, please go through my previous session. So we assume that it will work as a perfect switch. That means when it is on and it is off by the carrier signal, like a switching modulator, as I told you, the switching modulator principle. Now this is because the amplitude and frequency of the carrier is higher than the modulated signal. Now it is need to remember here, that is the important point, that the switching function of the four diodes, that means diode D1, diode D2, diode D3 and diode D4. The switching function of these four diodes, that means when these diodes will on and off, that will be controlled by the carrier signal, not the modulated signal, because carrier signal amplitude and frequency both are higher compared to the modulated signal. This is the important point you need to remember. Now, ring modulator working on two modes, you need to remember. Okay, this is the most important thing, that working of ring modulator based on two modes. The first mode is carrier suppression, when applied the carrier signal without the modulating signal. Okay, so first half, what will happen, the operation in the positive half of the carrier signal, and we will observe that operation in the negative half of the carrier signal. Again, it will happen when we will not apply the modulating signal. So this is the mode 1 you can see. And the mode 2 is operation in presence of modulating signal. Okay, so there will be again two states. The first state, the positive half of the modulating signal, and the second stage we will observe the negative half cycle of the modulating signal. So first we will observe the mode 1, that is known as carrier suppression. Okay, so what will happen now? Here we will assume that carrier suppression in first mode, the without modulating signal. So here you can see in this block diagram or circuit diagram, here zero modulating signal. So xt is 0. So there is no signal at the secondary winding of T1. So carrier signal is applied. Okay. Now we consider the first stage, that when carrier signal is positive. So when carrier signal is positive, that means plus minus here. So current through in this direction, this blue direction, it will goes to the secondary winding of T1. Okay, and when it is applied to the secondary winding of T1, that means it goes to in this direction. Okay, so at a node A, that means this at a node A. Okay, or you can see in this total ring modulator node A. Now observe this D3 and D4, because it is in positive signal, so D3 and D4 will be in negative bias. Okay, that means a reverse bias. So D3 and D4 will off, because it goes on, current goes to this direction and it is in reverse bias condition. Similarly, when current flow in this direction at for node B, when it enters for D4, it will also reverse bias. So for when carrier signal is positive, that means current goes to this center tap transformer T1 secondary winding, it goes to this node A and it goes to DB. Then D3, D4 will off immediately, act as an off switch, and D1 and D2 will be on. So this, that means current will go this, and D3 and D will, there will be no connection. So it will appear at the second primary winding of transformer, output transformer T2. Now at transformer T2, that primary winding of transformer T2, this current is divides equally at the upper and lower portion. So what happened? The upper part of the winding produces a magnetic field that is equal and opposite to the magnetic field produced by the current of the lower half of the secondary, because both are equal. So ultimately these magnetic fields cancel each other output and we will get zero output. There will be no output. It is written here, you can see that zero output. So carrier signal is suppressed. Effectively it is suppressed, because we give the carrier signal and we will get no output, although this carrier signal controls the diode D1 and D2 for its positive half. So remember that positive half of the carrier signal only diode D1 and D2 on, and D3 and D4 will off, and ultimately will get zero output. Now carrier suppression for second stage. Second stage, again modulating signal is 0. Now carrier signal is reverse bias. That means current flow in opposite direction. So current goes to the primary winding of the transformer T2, and it is again equal and opposite in direction. And now this will switch on the diode D3 and D4, right? But it will off the diode D2 and diode D1 and D2, because current is flowing this direction again. This not now. So diode D3 and D4 is positive right now. Is open, act as an closed circuit, but diode D1 and D2 is a open circuit right now. So current, so remember, for the negative half cycle of the carrier, diode D3 and D4 will be forward bias and D1 and D2 will be reverse bias. Now again at the primary winding of transformer T2, both current producing the magnetic field which are equal and opposite in direction. So again it will be mitigate each other or cancel out each other, and again we will get zero output. That means ultimately carrier is suppressed. So for the first mode, again I am repeating that for the first mode, when we apply carrier signal only without applying modulating voltage, the carrier is suppressed, because at the output we will get zero output. And for the positive half of the carrier signal, diode D1 and D2 is switch on, and D1 and D2 is switch on. And for the negative half of the carrier signal, diode D3 and D4 will be switch on, and D1 and D2 will be switch off. So this is the operation of the carrier suppression without modulating signal. Hope you will understand. Now we goes to the mode 2. Now in mode 2, we apply the modulating signal. So again there is two conditions. One is the positive half of the modulating signal and another is the negative half of the modulating signal. Now first, already I told you that the switching condition of diode D1 and D2 is depend on carrier signal, not on modulating signal. So when we apply modulating signal positive, the carrier signal is positive, so diode D1 and D2 will on and D3 and D4 will off. So if diode D2, D1 and D2 switch on for the positive of the modulating signal and D2 and D4 is off as written here. So what happened? At node A connected to node C, and node B is connected to node D. So this direction, the voltage across the secondary transformer T1 is transmitted directly to the primary winding of the transformer T2. So its original with its original polarity. So we get the output signal here for the first half of the modulating signal with the original polarity of the message signal, where carrier is already suppressed, right? Now goes to the second stage. At second stage, that means we are considering the negative half cycle of the modulating signal. We already know that for the negative half of the carrier signal, the D3 and D4 will switch on and D1 and D2 will off. That means node A to node D is connected and node B to node C is connected. So the voltage across the secondary of T1 transmitted to the primary of T2 with its inverted polarity. For the positive half of the modulating signal, the message signal will transmit to the output with its original polarity, and for the negative half of the modulating signal, the message signal is transmitted to the output with its inverted polarity. And for both the cases, carrier is already suppressed. So mathematically, ring modulator basically is a product modulator we can consider. Hence it produces the desired DSBSC output. Now the output is proportional to the message signal LT. Already we have seen the working principle. During the positive half cycle, it is proportional to positive MT, and during the negative half cycle, it is proportional to the minus MT we can consider. So M.T here, it is working on switching modulator, as I told you before. And in switching modulator, previously I told you in my previous lecture, when I already explained you the working of switching modulator, that in switching modulator we consider a square wave pulse. If you want to detail go through the derivation, please go through my previous lecture. Again I am repeating. So here we consider, already know, so I am directly considering the square wave pulse rate. WOT is multiplying with MT. So WOT directly can be written as, already we know that in this manner, 4 by pi cos omega ct minus it is a power series, 1 by 3 cos 3 omega ct plus 1 by 5 cos 5 omega ct, and dot 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 it goes on. So when it multiplies with omega 0 into MT, so it is multiplied with MT. Now this signal will pass through the band pass filter. Already we know the working of band pass filter. The purpose of band pass filter, it is pass the specific band and mitigate beyond this band and lower this band all the frequencies. So if we already know that ignoring the higher harmonic term, that means 3 omega ct, 5 omega ct, 7 omega ct, 9 omega ct, dot 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 dot, ultimately the output signal that will pass through the band pass filter, that will be 4 by pi MT cos omega ct, because there will be a LSB and USB only, and carriers is already suppressed. So ultimately, using a ring modulator, we will get the DSBSC signal, that is double sideband suppressed carrier signal. So basically it is you can say ring modulator based on the principle of switching modulator, and it is an example of double balance modulator, because we know that for center tap transformer how we can use a balance modulator. I already explained, again I am repeating the working of switching modulator, working on balance modulator, everything I will explain in previous lecture. If you want to understand clearly that the working of switching and balance modulator, let's go through my lecture with mathematical derivation, there I will explain. So ultimately this is the output waveform that will get at the output of ring modulator circuit. So this is the message signal we know, and this is the carrier signal. Because of the switching action, when D1 and D2 is connected, we will get this purple color waveform. Okay, now here this D1 and D2 is written in purple color. So in positive half, it will the positive, this square wave will get, and for the negative half cycle, again we will get the blue half, that means D3 and D4 is conducted, when then we will get this blue waveform. Okay, and ultimately this signal will passing through the band pass filter, and we will get this DSBSC signal. Now here you need to remember, again I am repeating, although I am repeating it previously when I will explain the balance modulator circuit, that when we draw the DSBSC signal in time domain, always remember at the 0 axis, when this signal is made at the V minimum will 0, there will be the phase change. Okay, signal will change its phase. Remember that, it is very much important. It is a common mistake that is practiced when we draw the time domain DSBSC signal. It is very much important, remember that. Okay, now this is the DSBSC output, original output, that I will generate using a music MATLAB simulation. So I generate a message signal, then I generate a carrier signal, that is a square wave, high frequency square wave signal, and after passing through the DSBSC modulator, which I create with block, we will get this type of waveform, that D1 and D2 on, and D3 and D4 on, and ultimately passing through the band pass filter. This blue line is the output of the balance modulator output, this, and after passing to the band pass filter, we will get the DSBC signal with the phase change at the V minimum 0. We will get the D signal that is passing to the band pass filter. Okay, so this is all about the ring modulator working, output, mathematical derivations, everything. Hope you will understand it and it is clear to you the working and everything of Ring Modulator. Thank you so much for watching this video. You can give your valuable suggestion and queries regarding what is required here in this analog communication engineering. Definitely I will get back to you based on your queries. So stay with this channel, keep motivating your friends. Thank you again for watching this video. May the God watch over you.